Okay, so there's no vocabulary this time, but there is a problem that I want to set up, and then when we get to the end, I'll show you the solution to it. Right now, it's just the general idea here is that there are recommended amounts of vitamins that you should get every day in milligrams, okay? For males, 75 milligrams of vitamin C. For females, 65 milligrams. Why females less? Because females, on average, have smaller body weight, okay? So everything but vitamin E, females need a slightly less. So if Carrie consumes 10 milligrams of niacin today, and her brother consumes 11, then who consumed the greater percentage of what they need to take in every day? And it's hard to tell because although she's taken in less, she also requires less. So we're going to be able to use the percent proportion to figure out how to solve these problems, okay? So just to set up, you'll see this later. Whoa, Mr. Massey, why are you shouting? I'm shouting because this is so important that I decided to make this one small, important proportion. The whole screen is over of equals percent over 100. I'm going to show you how to use it, but it's big because you need to copy this down, and you're going to use it for all of these problem types. Got it? Write this down. You're going to see how to use it in a minute. All right, so how do we use this? Well, this is how we use it, and it's really straightforward. We're going to replace three of these values here, is, of, and percent, with either a number or a variable that because we don't know that particular thing. And this is basically what we're going to do. We're going to identify in this sentence what percent of 56 is 42, and we're going to say, okay, what's next to 42? Is next to 42. So where we see is, we're going to write 42. What's next to of? 56 is next to of. So where we see of, we're going to write 56. And what is next to the percent? Well, next to the percent is simply what? And that means we don't know it, and we're going to put an X there. So this is what it looks like. Okay? 42 goes where is was. 56 goes where of was, and we're going to put P, or you could put X, where the percent is, because that's what we don't know. And then we do the cross products property. We multiply, remember, we multiply the diagonals. Okay? 42 times 100, and 56 times P. And then we simply solve it out. And what we find is that P is equal to 75, and so therefore, what we have as an answer is that 42 is what percent of 56? It is 75% of 56. Yeah, it's that easy. You're going to try this one right now. And again, the best way to do it is to box out what's next to is, what's next to of, and what's next to percent. And you'll notice that there's two numbers next to is, but one of them obviously is the only one that's going to go with is, because if you pair 90 with is, then there's nothing to pair 54 with. Okay? So figure that out, set it up, and solve it. All right, so the book shows you multiple ways of solving these, but I'm going to show you the same way every time. And this is the whole point, is that we're sticking with one basic principle here, which is identify what goes with is, it's 2.5, what goes with of, that's 40, and what goes with percent, and as you can see, it says what percent means we don't know it. So we would write it like this. The is number is 2.5 over the of number, which is 40, equals, we don't know what percent, so I'm going to call it X percent. And the 100 is what always stays the same. The 100 is already a number, and so we don't need to change that. That's what it is. Now when we cross multiply, we say 40 times X is 40X equals 2.5 times 100, which, fun fact, when you multiply a number by 100, you move the decimal two places to the right. So what we get is 40x equaling 250. And of course, as always, we're trying to isolate the variable, so we divide by the coefficient. And 250 divided by 40 equals 6.25. So then you can write that as, up here where it says is 2.5, you can say 2.5 is, and then this percent, 6.25% of 40. Okay? Try it with this got it problem. Okay, what do we do for this one, this word problem? Well, it says a dress shirt normally costs $38.50, and it's on sale for 30% off. The trick with these types of problems is if you're saving 30%, then what percent are you paying? And you can see that if you take 30% away from 100%, the sale price is going to be the other 70%. So what you can do is you can take your is over of equals percent over 100, and you can say, okay, we know what the percent is. We know that it's 70%. But we're taking some percent of the original cost. And this is where you have to just speak it out and make sense of it, okay? So we don't know what the sale price is. What is, notice right here, what is, okay? And it's, what is the sale price really of, for over here, of the original cost of the shirt. So what is the original cost? The original cost is $38.50, so we're going to put that on the bottom. $38.50. We don't know what the price is, so we put X there, but we do know what the percentage. We're paying 70% over 100. And when we multiply that, we get 100X equals 70 times 38.50. Which is 2,695. And just like when we multiply by 100, we move the decimal over 2 places to the right. When we divide by 100, we move it 2 places to the left. And I'm going to work it over here now. We say then X is equal to 26.95, or another way of saying it is that the sale price of the shirt is $26.95. Okay, and let me give you got a problem here. All right, we're going to do the same thing. What you should be doing here is always starting out with is over of equals percent over 100. Trust me on this, you want to start writing these down like that right away. Now what are we going to do? We're going to say, oh, we know what the percent is, it's 125%. And then of what? The of number is what we don't know, and is 17.5. So how do you write that in? You say, okay, well then, 17.5 of what is the X equals 125 over 100. And notice this little note here that they give us. Will 125% be greater than the number? Yeah, anytime you go above 100%, you're taking more than the entire number. And yeah, there's a lot of situations where you can have more than 100%. So that's not strange, okay? And we cross multiply, and so what do we get? We get 125x equals 17.5 times 100, which again, when you're multiplying by 10 or 100 or 1,000, a 1 with however many zeros behind it, you move the decimal to the right however many zeros there are if you're multiplying. So since we have 2 zeros and we're multiplying, we move it 2 places to the right and we get 1,750. And then of course we need to divide both sides by 125. And I'm sure I had the answer written down here somewhere because I don't have this calculator. I guess I can divide it over here. Might as well just do the division, show you how to do it. We're dividing this by this. Okay, now 125 won't go into 1 and it won't go into 17, but it will go into 175 one time. So put a 1 there and subtract the 125 from it. We're left with 50. When we bring the next 0 down, we get 500, and there's actually 14 groups of 125 exactly. And so what we get is that x is equal to 14. So therefore, what can we say? We can say, and I'll write it out, 17.5 is 125% of what number? 14. And it makes sense. 14 is smaller than 17.5 because 17.5 is greater than 100% of it. Okay? So here's your got it problem. All right. So we're back to this original problem that we were talking about, which is this. Okay? We've got Carrie and her brother each having some intake of niacin, and we're trying to figure out who's got the greater percentage of their daily necessary intake. Okay, and this is what it looks like. We say, okay, well, Carrie is taking in 10, it tells us right here, of how much does a female need? 14. So 10 out of 14 is what percentage out of her 100%? Same thing over here with her brother. Her brother's taking in 11 out of his daily intake, necessary intake of 16. So what's his percentage? Well, if we cross multiply, we can see for Carrie, it's 14 times x equals 10 times 100. And for her brother, it's 16 times x equals 11 times 100. And when we continue doing the calculations, we get 14x equals 1,000 for Carrie, and 16x equals 1,100 for her brother. And what do we have to do? We need to divide both sides by 14 for Carrie and divide both sides by 16 for her brother. And what do we find out? We find out that for Carrie it is approximately 71.4 and her brother is approximately 68.8. So we have Carrie takes in 71.4% of her daily intake and her brother only 68.8%. Okay, so who consumed the greater percentage of their recommended daily intake? Well, that, of course, would be Carrie at 71.4%. Okay, I've trimmed off the got it problems to just these 4 that you should identify what is the is, what is the of, what is the percent. And one of them is going to be a variable that you're solving for. Okay, try and do these. Like this is a great practice right here. So do these, come back and compare your answers. Okay, good luck with this.